Top drawer of my desk. 3H. Simplify rational expressions. I can simplify rational expressions. That's the goal. We have 3 steps here. Read for me number 1, or A, Dylan Asbury.
Read it.
Hang on, let me write my name first. Okay.
Can I read?
Steps, simplifying
I wanna
rational.
read
You just
too.
want me to read it?
Yes. Read H.
Factor the numerator and the denominator.
Thanks. Step B.
Determine the domain.
Number step.
C.
C.
Mark off.
Mark off whites.
Great. We're going to see how this works here. In number 1, factor the numerator and denominator. The thing is, if you already have monomials, you can't factor that. So we're going to skip to step B, which says determine the domain. Remember the domain when you have rational functions? What is not allowed to be 0?
The 0. I mean, the denominator.
The denominator can't be 0. So we're going to just go, okay, 4x can't be 0.
We're just simplifying.
Therefore, x cannot be 0. That is the domain of this rational function. So that's the first thing.
How is it rational if it's not working?
So what does that exactly like?
So rational just means, so the question just came up, what does rational function mean? Rational just means that you have a variable in the denominator. That's a terrible. Variable in the denominator. So now that we found the domain, it's important to know what the domain is because that excludes some values for x right off the bat. And then we do what we did in the opener. So 24 over 4. If there's a monomial in the denominator, yes. And it says that up there. If you have a monomial in the denominator, your domain is always just going to be x cannot be 0. But you'll see we get some binomials in here, and then if you flip to the back, we're going to get into some trinomials. So there are other occasions where it's not just 0. So 24 and 4 have a common factor of, you guys got this. So we're going to divide those both by 4. 24 divided by 4 is good. And then I have x cubed over x to the first.
So the x squared.
Top or bottom?
The top.
Top, because that's where the larger variable is, so that's where the variable lands, x squared. And it's all over 1, but nobody writes that as a final answer. It's not simple. The simplest way to write it is just 6x squared. We just simplify number 1. Number 2.
Number. Dos.
Turn off the heat.
Numero. I know what it is. I just said number.
Number 2. Here it comes. So 18 over 4. What is a common factor between 18 and 4? Yes, just 2. See, this is the hardest part. Just figure out what goes into both of those. 18 divided by... Yes, 9 over 2.
So then it will be 9 over 2x squared.
Yes, ma'am. With the x's, we have the 3 minus the 1, because those are your exponents. So you're going to have x squared. It lands where the larger of the 2 exponents is, so that's going to land in the denominator.
So, how do you determine if the exponent's going to be on the numerator or the denominator? What's the...
Wherever the larger exponent is from the original expression, that's where it lands. So as you can see, this has a monomial in the denominator. So again, what's the domain?
Can't be 0.
You got it. X can't be 0.
So what's a monomial? I mean, this is kind of a stupid question. What's a monomial?
Don't worry about it. It's not a stupid question. A monomial is where you just have one term. So here, terms are separated by a plus or a minus sign. Since there's not a plus or a minus, then we only consider that one term. Okay, down here, there are 2 terms because there's a plus sign between, so that's called a binomial.
And then 14 divided by 14, it's the same, right?
So we can't divide across an addition sign. So we do need to factor this first. So we look for the common factor between 10 and 14. 2. So we're going to factor out a 2, leaving us with 5x plus 7.
Over 14.
I'm going to cross out that denominator that we previously had. 14 is still in the numerator.
How do you get 5x plus 7 again?
Because I divided 14 by 2, since that's what I factored out. I factored out a 2. 14 divided by 2 is 7.
And then 5x is the 10x divided by 2?
Yep. That's what it means when you're factoring. It means you're dividing by that number. So now I can look for a common factor between 14 and 2. 2. I'm going to divide these both by 2, divide by 2, and I get what's 14 divided by 2? 7 over 2 divided by 2 cancels out. That's just 1. And I have 5x plus 7.
So what you factored out is what you have to take up top.
What you factor out is what you take out. You divide the numerator and denominator both by that. 7 over 5x plus 7. Again, you can't simplify across an addition sign. So we can't go, oh, 7 over 7, that's a 1. No, you can only simplify common factors, things that are being multiplied. So then again, now on this one, we would say for the domain, 2 times 5x plus 7 can't be 0. You kind of learn some patterns to make this go a little quicker, but if we divide 0 by 2, what do we get? Still 0. So we're going to just, okay, divide by 2, divide by 2. So now 5x plus 7 can't be 0. Just solving a simple algebra, subtract 7, yep. So 5x can't equal negative 7.
So we divide 5 by 6. So x can't equal.
This is the domain. So there's two parts to what we're doing now. We're simplifying the rational expression, and then we're also finding the domain. So there's always, if we have variables in the denominator, there's always going to be values for x that make that denominator 0. And we have to identify what those are and express that that is not a value that's allowed for x.
Okay, so we always find the domain,
Mm-hmm.
and then it's always just like somewhere.
Yep, setting the denominator equal to 0 or not equal to 0. Yep, so ultimately the domain here is x cannot equal negative 7/5. Next up, we have number 4, and you see the common factor here. First, looking at the 10 and the 2, common factor is 2. How about between the x cubed and the x squared? Yes, ma'am. X squared is the common factor there.
5x minus x. Oh wait, just kidding. Where's she at? Did she just...
Alright, so your 8x squared comes out, and 10 divided by 2 is 5. X cubed divided by x squared is x. And what's 2x squared minus, or divided by 2x squared? It's 1. So now our denominator becomes this thing.
And then we divided by 2x squared of both denominators.
Yep, and you see that common factor now, where 2x squared and 2x squared, that's what makes the 1. So that's what we cancel out.
Then you have 1 over 5x.
Yep, don't forget the 1 in the numerator. It's not just 5x minus 1. It's 1 over 5x minus 1.
And that's the simplified fraction that we're in
This is the simplified rational function. And now, to find the domain, I have to go back to my original denominator. I can use the factored form of it. That becomes helpful when we have this type of problem because it's already factored for us. And that's how we would solve this anyway, is by factoring. So step 1 is already done for us. And then we set each term here equal to 0. So either 2x squared cannot equal 0, or 5x minus 1 cannot equal 0. What value for x here would make this expression 0? 0. So I'm just going to jump to that thought. You could divide both sides by 2 and then square root both sides. But you don't really need to do that if you notice that that's just a monomial set equal to 0. So an x equals 0 makes that 0. For this side, you add 1 and divide by 5. So x can't be what? Add 1 to both sides. So then 5x can't be 1. Divide both sides by 5. So 1/5. X can't be 1/5. That's your domain. And that's also, those are both going to be asymptotes. So remember, we talked about asymptotes on the graph. This graph is going to have 2 asymptotes, 2 vertical asymptotes. It's a great word. Number 5. Factor the denominator. There's a common factor there. What is it? 3. So we're going to factor out a 3. And here you can see already we have the common factor of, it's like a treasure hunt. You already found the x plus 2, that's what they had in common. And now you get to cancel those out, and your final answer is just 1/3. Your simplified rational expression is 1/3.
Wait, how'd you do it?
The numerator, x plus 2 is canceled out. So what's left if things cancel out entirely? Like in the numerator, it's a 1 that's left there. And the 3 is left in the denominator. What? And now for the domain, we say, okay, so 3x plus 2 can't be 0. Divide both sides by 3, it's still 0. So what can x not be? X cannot be, so x plus 2 cannot equal 0. Subtract 2 from both sides. So x cannot be what? 0 minus 2 is -2. X cannot be -2. If we subtract the 2 from both sides, we find x cannot be negative.
What that sign means cannot be.
Does not equal. That sign means does not equal. All right, the common factor then for our, this time we have a numerator that has, that can be simplified or factored. I mean factored. What is a common factor between 3x and 18, Zach? 3. Good. So I'm going to factor out that 3. I don't have room to write it above.
So we're starting from the top down.
Anything that can be factored should be factored. Previously, we haven't had a numerator that could be factored. This is the first one where we could factor something in the numerator, and then again in the denominator, so we have 2x squared and 12x. What's the common factor between 2 and 12? 2. And between x squared and x? X. So 2x squared divided by 2x just leaves us with an x. And 12x divided by 2x is just 6. Good. And there it is. This beautiful thing happens where you have things that cancel out. 3 over 2x. And then we find the domain. 2x times x plus 6 cannot equal 0. And then that sets us up to say, okay, either 2x cannot equal 0 or x plus 6 cannot equal 0. Divide both sides by 2. 0 divided by 2 is 0, so my domain ends up being x cannot be 0. Subtract 6 from both sides on this one, so x cannot be what? Negative 6. So again, you would expect if we were graphing this to find two vertical asymptotes, one at x equals 0 and one at x equals negative 6. Number 7. So v plus 5, that cannot be factored, but v squared minus 25, that's just like our last two on Friday that we factored. Valkyrie, do you remember how to, I think you said it, how to factor v squared minus 25?
Oh, yeah, it's the perfect square. So, it would be b plus 5 and b minus.
Yes, that's it. So that's how you factor the difference of perfect squares. Write it on your paper. Okay, but write it on your paper.
Wait.
So that's what the denominators became a v plus 5, v minus 5. That's how we factored the difference of perfect squares. So back from unit 1, when we have a binomial, such as two terms, if it is in the pattern of the difference of two perfect squares. So in this case, v is a perfect square because it's v squared, and 25 is a perfect square. And we're subtracting them. It fits the pattern, so we know that it can be factored into a plus b, a minus b. So we just take the square root of each one of those and do the sum and the difference. Do your cell phone? In your lap. Thanks. Okay, so then again, v plus 5 over v plus 5 cancels out. So what's your final answer if those two cancel out? 1 over v minus 5. And we have this domain of v cannot equal v plus, nope. V plus 5 cannot equal 0, and v minus 5 cannot equal 0. Leaving us with what two values is v not allowed to be?
Is that downstairs too?
Yeah, that's the,
He doesn't have a.
they should have, she says,
All right, last one on this page. How can we factor that numerator? X squared minus 36. What pattern is that, Leslie?
that's Allison.
X squared minus 36. How does that get factored?
How do you?
Leslie? How do we factor x squared minus 36?
You want to factor the
No, x squared doesn't divide by 2. Evan?
is it x plus 6, x minus 6?
It is. Nicely done. That's the difference of perfect squares again. So x plus 6, x minus 6.
Can I guess what it's going to be after?
Well, the denominator, what can we factor out of the denominator? 2, and then we have x minus 6 remaining.
So it's just 1 over this.
No, not quite. So those two cancel out. Well, the x plus 6 is in the numerator, right?
2 plus 6 over 1.
How about just x plus 6 over 2?
Oh, alright.
How about that?
He's stupid.
Sorry, guys, alright?
All right.
Oh my god, it's freezing in here.
So then, what values is the denominator not allowed to take on? Add 12 to both sides. So 2x can't be 12. Divide both sides by 2. So x cannot be what? 12 divided by 2 is 6. So x cannot be 6. That's your domain. You have questions that you can now work out on your homework. I'm going to give you about 12 minutes to work on those. You can do every question except 10 and 12.
So don't do those at all.
Don't do those yet. We're going to do those later. But for now, go ahead and do every other question on your homework assignment to practice.